Question 1 says a pile driver is a heavy weight that is allowed to fall on a post and drive it into the ground. A pile driver has a mass of 500 kilograms and is allowed to fall through a height of 1.2 meters. Assuming all its potential energy becomes kinetic energy just before it hits the post, find its kinetic energy. So in this particular case, we know that the gravitational potential energy that it had at the top all gets converted into kinetic energy. So what we're really trying to calculate is its gravitational potential energy at the top. So the gravitational potential energy is equal to mgh, or mg delta h if we're being a bit more careful. Mass is 500. G, we should be using 9.81 for A level, not 10. And the height it falls through is 1.2 meters. Giving us a value of, so on the calculator, we're thinking about significant figures, it comes up as 5886. But within the question, this is our clue, I think, on significant figures here. We've got 2. This number doesn't tell us much, does it? It's either 1, 2, or 3 significant figures, that number, but this one's definitely 2. So we should write this as 5,900. Sorry, joules is the amount of energy, isn't it? Part B, on hitting the post, it drives it 0.7 meters into the ground. All of the energy of the pile driver does the work on the post. Find the average force acting on the post. So we know that the work done, or the change in energy, is equal to the force multiplied by the distance in the direction of the force. Just write Fs, so force times displacement. Here we're trying to find the force, so that's the energy transferred divided by the displacement. So the energy transferred was 5,900. So we should use the rounded value from above in a question like this, and we're going to divide it by 0.07, which is the distance it moved through. So this should give us a value of 84,000 newtons. Now, I've done this to 2 significant figures. In a second, I'm going to go and correct this in the question. So there's an extra significant figure in here, so that we've got it definitely to 2 significant figures. So that should give us 84,000 newtons.